Hello everyone, welcome to Decoding. In the previous video, we have solved our valid anagram problem using two approaches. The first one was brute force approach and the second one was sorting based approach. But in today's video, we are going to optimize it further and we will see the optimal solution for this type of problem. So let us come towards the solution as we already understand the problem statement. So the problem statement was saying that we have two strings and we have to match are those strings valid anagrams of each other or not. So let me bring you towards a solution which we can implement as dictionary based approach. So the solution is something like this. Let me first give you the solution and then I will explain you each and every line of that particular solution that we are using. So first of all, it is very much obvious that we are checking the length at the very first. And let me change the color of the pen also to be more concise. So this is optimal solution and I will be explaining why it is the optimal solution. So the very first is if we have the length not equal to the length of t, then definitely we return false here, because S and T are not matching in terms of length, then how they will be matching in terms of anagram concept, right? Now I will be creating an empty dictionary and think of this like an empty notebook. It is an empty notebook, all right, and in that notebook we will be writing the counts or something. Let us see in the solution further. Now this is the empty dictionary. I named it fric, which is frequency for, right? We will be catching up the frequency of each character in both of these strings. You will definitely come towards the solution, don't worry. Now let us see. We will be running a for loop and we will say for character in S, if my character is present in S, then I will be increasing its frequency of that particular character. And as I said, dictionary is something like key value pair, then definitely this character will be there and has to we are putting that character into that if that character is in S. So we are you can say filling our notebook with that particular character. I will be explaining you with the example, don't worry. So if that character is in S, then increase that frequency. So we will something say like frequency dot get, and we will increase it to +1, right? Increase the frequency of that character. First of all, we put the frequency of we put the character into the dictionary, we initialize it with 0, and then we increased the frequency of that character to 1, right? This is the approach. Now coming towards another for loop, for which for character in T, I have to check that character in T also. And if that character is present in T, but I have to check the statement, if my character not in frequency. Now what does it say? If the character is in T but character is not in frequency, and frequency contains all those characters which are present in S, so indirectly I am saying that if character is in T but it is not present in S, then simply I can say we do not have an anagram and we return false. I hope you're getting this line. If the character is not in S but it is present in T, then definitely we return false. Once again, but if it is present in T also and present in frequency also, so it will be false, then we will come towards reducing the frequency of that character. And I will say frequency of that character, reduce it to 1. Like you can say minus minus or minus equals 1. All right, so we are reducing the frequency of that character by 1. And one more time I will check if that frequency for each iteration for that particular character, if the frequency has been reduced to even less than 0, that means it became negative, then this simply says that this character is present in extra amount as compared to S. Alright, so then again we will be returning false here. And to all this, if everything goes well, then we return true. Right? Now let me explain it to you in more clear manner how it is working. Right? So here you will see we are checking the length of the character. If length doesn't match, then it is returning false. These two statements are very much clear. We are creating an empty dictionary named as frequency, and there we will be checking our putting our you can say, I'm sorry about the battery. And here we are having the frequency dictionary, which will be storing the frequency of the characters. So it is something like this. So you see, for that character in S, if we have earth and heart, then you will see the very first character is E. So E will be stored with the frequency of you can say E is how many times E is present here. So the very initial is 0, but as it is iterated to 1, then it will be increasing to 1. It has the frequency of 1 right now. So we can say it has a frequency of 1. All right. Now coming towards this once again we will check to A. We will come to A, and we will say if A is present in the frequency, no, it is not present in frequency, then put that into frequency dictionary and then iterate it to again 1. All right. So from 0 it becomes 1. Once again we will come towards R. R is not present here. R will be put, and the frequency of R will be 1 here. Coming towards T, once again the same way, it will be 1 here. Once again for H, it will be 1 here, right? So you have seen that this box is containing the characters and their frequencies, right? Now we will be checking the characters of T also. All right, and we will say if that character, if my H, supposing CH is pointing to the very first character in the T string, if my H is not in frequency, I am saying that if H is not in frequency, bro, is H is not present in frequency? False. It is present in frequency. All right, so it becomes false, and it doesn't go inside the if statement, and we come here, then reduce the frequency of that character to 1 less, so it becomes 0, right? Now we say if that frequency of character is less than 0, no, currently it is not, then iterate over to next character, then we iterate over to next character, which is the E. Now we will check once again, if this is not present in dictionary, false. If it is present, then reduce it, then it will become 0, and then check, is it less than 0? No, currently not. Then for A we will see, that if that character is present in dictionary, right, it is there, and reduce it to 0. Then for R also reduce it to 0. Then for T also reduce it to 0. So you see all the frequencies become 0, and this simply states that the length of the this simply states that the character frequency in S is exactly matching to the character frequency in T, which means S or T are valid anagrams of each other, right? Have you understood the problem? Have you understood the solution? Now let me introduce an extra character E here to get more about this particular statement. Now if I have an extra character E here, then I will iterate over to this, and I will say if character present in that is frequency, yeah, E is present in the frequency, right? But I have to reduce it by 1, and it gets to -1, and when it gets to -1, I will be checking if the frequency of character is less than 0, which is less than 0, then we return false. And this simply says that some extra characters are there. Or you can say you have one basket and you have another basket of fruit basket, then you have fruit basket burn and fruit basket second. Then here you can say that if it has one apple, one banana and one mango, and there are two apples like a and banana and mango, then if you reduce the frequency, then it will become 0 0 and 0, but the frequency will become of a to -1, which means the t string, or you can say the second basket, contains some extra fruit, or the same fruit with some extra frequency, right? This is the approach that we are going to solve. Let me bring you to the solution very quickly. We will be checking the length of s, and if it doesn't matches, then we return false here. We initialize an empty dictionary, and we say for character in s is present, then frequency of character get is a function, do not worry about that, right? ch0, and we say iterate it with 1, right? Now for character in t, if that character is present in t, if that character not in frequency, present in t but not in frequency, or you can simply say not in s, then definitely we return here false, right? Otherwise we say frequency of character will be reduced to -1. All right, and if my some frequency of character is less than 0, then I simply say false, because something is extra there. Now I return to true. So let us check the solution and run it and check if it passes the test cases. Definitely it is passing all the test cases, and if I submit it over here, you will see here that we have 11 milliseconds of runtime. And I do not generally bother about beat percentage, because it is a little bit of depends on the interpreter right now. Okay, so this was the solution, and if I bring you to the time complexity very fast, then you will see here that this for loop is going till order of n times, and this for loop is once again order of n times. But these are independent of each other. They are not dependent on each other, they are independent. So it will be something like order of n plus order of n, which will be giving its time complexity to order of n. And then you will realize that in the very first brute force approach, we have solved it to order of n square. Then we optimized it using sorting technique to order of n log n, and then we optimized it further to order of n. But here we will have some extra space, so the space complexity will be something like order of you can say order of k, right? You cannot say order of n, because we are having the frequency of characters. All right, so this is order of k. And in more you can say simple approach, you can be like, I am a little bit nervous about telling this thing that it can be order of 1, right? Because the characters are 26 only, right? If you are talking about small case characters, then they are just 26. So the space complexity optimization is nothing much bothering here. So it will be order of k in terms of how many characters frequency they have. So this was the approach that we have solved using our manual dictionary. But Python has something more interesting for you. Python has something more interesting for you. In Python, we have collections, like in C++ we have STL and all those. So in Python we have collections. So collections contains one function which we say counter. Do you know what I'm telling? We say to that as counter, and that counter is just the sub implementation of the hash map. So nothing sort of different out of that, but all these things that we are doing here, they will be abstracted in this counter function, right? So we simply say the function as counter of s, like we did in sorted approach. Counter of s is matching with counter of t, and nothing changes with the time complexity and space complexity. You will see here order of n, and you will see here space complexity as order of k itself, or order of 1. You say I do not bother about that. Now let us come towards the solution in terms of counter. but for that counter we have to you can say get the collections, like from collections import counter. So from collections we are importing counter, and lastly we are simply saying return counter of s equals I'm sorry about that, counter of t, and if that matches then we return true, otherwise false. So we have successfully passed our test cases, and then you will see here the time complexity will increase to much more. It is 89.41 and 7 millisecond. Doesn't matter at all. We have to understand the concepts in depth. All right, guys. So I hope you like this video. If it definitely brings some value to you, then please share it, subscribe to my channel, and like all the videos of the channel. Okay. Till then, signing off. Decoding.